Okay, in this video we are looking at linear equations and some applications of those, and then we'll finally look at something called zeros, which is a way of solving, well, you solve a linear equation in order to determine the zero. Okay, so when we're solving linear equations, here's just some general tips. Want to get rid of any brackets that you have. So by using the distributive property, collect like terms if you need to. Get all your x's on one side, numbers on the other side. Then you use either the multiplication or division principle to solve. And then in solving any equation, it's a good idea to check your answer to see if you're correct. I'll do one, you can try one. You've probably done lots of these questions. I purposely put in a couple of questions, this one and the next one, that have a negative sign in front of a bracket. So make sure when you have a negative out front of a bracket, you're worried about that. My favorite name for that, of course, is the dirty, rotten, filthy, stinking negative. Okay, so in this question here, we need to use the distributive property here. So it'll be 2x plus 4. Use the distributive property here. So minus 3x minus 1 is equal to 7. That's the sign there that lots of students mess up on. Okay, collecting like terms, I have a 2x and a minus 3x, so that'd be a minus x. And then I have a plus 4 and a minus 1, that would be a plus 3, is equal to 7. Now feel free to skip as many steps as you want here, as long as you're not making a mistake. Like I was going to take the 4 and the minus 1 to the right side and change their sign, but I decided to just throw another extra step on this left side. But skip as many steps as you can, as long as you're not making mistakes. Putting more steps in, nothing wrong with that, and it's actually a good idea. Okay, now I want to get the 3 to the other side, so I'll subtract 3 on both sides. So I'll have negative x is equal to 4, but I don't want a negative x, I want an x. So I'll divide this side by a negative 1 and this side, so I get x is equal to negative 4. Let's just check this question and see if it's right. So here's my original question, x plus 2 minus x plus 1 is equal to 7. Always make sure I write it down right. Okay, now I'm going to put a negative 4 everywhere I see an x. Negative 4 plus 2 minus 3 times, whoops, a negative 4 plus 1 is equal to 7. So negative 4 plus 2 is a negative 2 minus 3 times negative 4 is negative 12. See, I'm slowing down, just doing one step at a time. 2 times minus 2 would be a negative 4. Here, minus negative 12 plus 1 is negative 11. It's equal to 7. And now these two minuses will make a positive, so it's minus 4 plus 11. And that indeed equals 7. Therefore, an answer of x equals minus 4 is correct. All right, try one on your own. Try it, notice the dirty, rotten, filthy, stinking negative, press play when you're ready. So distributive property, be 3x plus 3 equals 5 minus 6x minus 8. That whole thing needs to distribute to both of those. So I have 3x plus 3 equals 5 take away 8 is a negative 3 minus 6x. Let's move the x's to the left side, so I'll have 3x plus 6x is equal to, over here already I have a minus 3. If I bring this over, it'll become a minus 3. 3x plus 6x is 9x. Negative 3 minus 3 would be a minus 6. Dividing both sides by 9, I get negative 6 ninths, which I can simplify to negative 2 over 3. Again, a good idea, and maybe you can try your calculator, see if it does all this for you. So let's put in our 2/3, negative 2/3 right here, plus 1. So do that on your calculator, see what it comes out to. I think it comes out to 1. Yeah, I think it's 1. Is equal to 5 take away 2 times 3 times negative 2/3 plus 4. Okay, hit that on your calculator. Hope it comes out to 1. That'd be negative 2. That'd be 2. 2 times 2 is 4. 5 minus 1. Yeah, it comes out to 1. So that therefore, negative 2/3 is our answer. Okay, now let's do some worded problems. Everybody's favorite or least favorite kind of thing. I find that worded problems and applied problems, regardless of whether they're linear equations or quadratic or whatever, it just takes practice and doing lots of questions so you are familiar with most any way they can ask you the question. The steps they have in the textbook are good. Familiarize yourself with the question, draw pictures, distances, whatever. And then on those things, put some variables, put some X's and Y's or Z's or whatever else you need. Look at the relationship between those things and come up with some kind of a formula. And then do the math, actually solve for one of the variables, check to see if you're correct, and lastly, state what your answer is. Let's try those steps in a number of different kind of questions. Feel free with all these questions to try them on your own without me going through them, and then come back to see if you came out right. Okay, it says the width of a poster is 2/3 of its height. So the width is 2/3 times the height. So if this is the height, then this would be 2/3 times the height. And its perimeter is 100. So the perimeter is 100 the whole way around. The whole thing is 100 meters. That's a big poster, 100 meters. Maybe it should have been centimeters, whatever. Okay, so they say find the dimensions. One of the concepts that I'll need to worry about here is perimeter. I know the formula for the perimeter of any rectangle is 2 lengths plus 2 widths. So if they say the perimeter is 100, I can put that right in for P. And then, now here it's 2 lengths and 2 widths. In this case, we're using widths and heights. So instead of maybe that L there, I'm going to put in an H. So 2 of these H's and 2 of these, this is a width, this is a width. But we figured out that the width is actually equal to that. So let me write that 2/3 H down here. Okay, so 2 times the height plus 2 times, now the width we said was 2/3 what the height is. Okay, so now I've got, here's a good question. Again, pause if you want, and then try it. Okay, so they say the base salary of a salesperson is $2,000. On all sales they're responsible, they get 6% commission. So their paycheck is $27.90 plus how, so they want to know how much did they sell that month. Okay, so their salary, or how much money they get a base salary plus they get commission. And all told, that's $27.90 in a month. Okay, let's plug some stuff in. So their base salary is $2,000 plus, now to get their commission, you would multiply 0.06 multiplied by whatever their sales are for that month. I'll just put sales. I'll put S for sale. I'll put sales. So 0.06 times whatever their sales is, that's how you get your commission. And that's all equal to $27.90. So here's a nice linear equation to solve. Subtract 2,000 on both sides. So I get 0.06 times sales is equal to 790. And then divide both sides by 0.06. So I get my sales are going to be 13,166.67. So that's how much they sold that month. Oh, here's a nice question. It involves cycling. Cyclist leaves Lethbridge traveling east at 40 clicks. A car leaves an hour later traveling 100 kilometers an hour. When will the car catch up to the cyclist and how far will the cyclist have gone? For these questions where you have a distance, a speed, a time, it's useful, as they say in the textbook, to use a table. So I like putting distance first, and then their rate, and then their time. So let's look at the cyclist, and let's look at the car. So the distance they travel, they both, well, we want to know when the car catches up. So the distances are going to be the same. We don't know what they are, but they're both going to be d. Okay, the rate of speed, the cyclist is going at 40, whereas the car is going at 100. Okay, for time, they don't give us a time either, but they do say when the car catches up, but he leaves an hour later. So if I say that the cyclist time is t, then the car will also travel t, but if it leaves an hour later, it'll be t minus 1. So here's a table that I can use to help me look at the relationships between them. In both cases, the distances are the same and the t's are the same. The car has traveled 1 hour fewer, but the value for t will be the same. So if the cyclist goes 10 hours, then the car will be 10 minus 1, or 9 hours. Now, there's a formula that says distance is equal to rate times time. So I can use that formula to help me out in this question. So let's look at the cyclist first. Let's use the formula. Distance is equal to rate times time. So its distance is, we don't know, is d, but then its rate is 40 and its time is t. Okay, so there's a relationship between d and t. Let's look at the car. So the car, same formula. This time it'll be distance is equal to 100 times t minus 1. Okay, so there's the formula for the car relating distance and time. But I know, and I'm just going to write that, but the distance that they each travel when the car catches up will be the same. So if this d is equal to this d, it follows that, let me use a different color, that this must equal that. So let me write that down. 40t must equal 100 times t minus 1. So this is like the cyclist on this side, and this is the car. Now it's a linear equation. Let's solve. Let's get rid of brackets first. So it'll be 100t minus 100. Let's subtract 40t on both sides. So that'll be 0 is equal to 60t minus 100. Let's add 100 to both sides. So I get 60t is equal to 100. And then we'll divide 60 by both sides. So it'll be 100 divided by 60, which when I simplify that, 10 over 6, 5 over 3. So 5/3, that's how long it'll take. That's 5/3 hour. That's like an hour and 40 minutes. 5/3 is be 1 2/3. I guess if you wanted to times that by 60, it'll tell you how many minutes it took. But it'll be about 100 minutes, hour 40. So that is the question. When will the car catch up to the cyclist? After the cyclist leaves, about an hour and 40. Now then the question is, how far will the cyclist have gone? Well, I can use that 5/3 and I can plug it into that formula or that formula, and that'll tell me the distance. Let's plug it into the first one, 40t. So the time is 5/3. So it'll be 200 over 3. What's that come out to? 66.6 something, 67 kilometers. So the car won't catch the person until, I don't know, they might be at Grassy Lake, somewhere in there. 66.67 kilometers after. Okay, last concept for this section is looking at zeros. And the zero of any function is one where you're looking for what the x value is when the y value is 0. Another name for zeros that we'll say in the future relates to graphs. And what they are is they want to know what the x value is when y is 0. So anywhere along this axis. So they want when x is 0, they want to know when y is 0, they want to know what that x value is. And so to do that, you just substitute a 0 in anytime you see a y or an f of x. So in this first one, I want to solve for the 0. I put a 0 in for y. And then solve for x. I'll subtract 5 on both sides. Then divide by 3. I'll get negative 5/3. Notice this one is the same. You just put a 0 there, and you'd be solving the same thing. So this is known as the solution to the equation, but it's also known as the 0 of a function. Why don't you try? So what is the 0 of that function? Press pause, press play. So I would put a 0 in where f of x is. Notice that I didn't go what's f of 0. That's a different question. F of 0 is saying if x is 0, what is y? Or in other words, what is the y-intercept? But we don't want that. We're wanting the 0 of the function. I replace that whole thing with just 0. Now let's bring the 2x over to this side and make it positive. Divide both sides by 2, and I get negative 4. So the 0 of that function is negative 4. So in this video, we've looked at solving linear equations. I've given you 2 or 3 examples of worded problems that you might run into. And again, practice, practice, practice those. And send me questions if you have them. And at the end there, we also looked at what the 0 of a linear function would be.